Okay. Good to see you. And you should say, good to be seen. That's my response when people say, good to see you. When you get older, you feel that way, you know. Well, listen, it's a pleasure to have you here, and we are really blessed to have Russ Humphreys here with us this evening. So let me give you a little bit. I know a lot of you do get the newsletter, and I just rehash what the newsletter has. But if you don't remember it or whatever, I'll just give you a little recap, okay? All right. So Russ is a creation scientist, but he hasn't always been that way. But most of us who are creation scientists have not always been that way, you know. We had a conversion experience. He now lives in Chattanooga, Tennessee, and he he's been around different places, but his last place of engagement was with CMI, Creation Ministries International, then previously with ICR, Institute of Creation Research in San Diego, which is now in Dallas, Texas. Russ received his bachelor's in '63 from Duke University, got his doctorate in '72 from LSU, Louisiana State University. He was in Sandia National Laboratories in Albuquerque, 2001. Is that about right? Yeah, about right. New Mexico, and then for 22 years, physicist doing different things that Sandia does. Among them, various geoscience researches and stuff like that. Then he went in high voltage research with General Electric. Some of that work published some numerous professional publications in scientific journals. Has 3 patents, 2 industrial research magazine IR 100 awards, and of course several other awards, Sandia National Lab Award for excellence. He's, as some people have come to the mill as an atheist, that's what Russ was at one point in his life. He told me his conversion experience on the way over here this evening. I won't share that with you, but I'll just tell you he received Jesus Christ in '69, right, when he was a graduate student. And a few years later, he had overwhelming conviction about, you know, the truth was in Scripture and not in evolution, or what science was saying about it anyway. Geologic ages were not the long ages. It was scripturally identified in Genesis, no more than 6,000 years. His main research interests cover the age of the Earth, magnetic fields, not only with regard to the Earth, but with regard to planetary fields as well. Sediments in the ocean, salt in the ocean. You probably read some of the work in the RATE project with the helium diffusion. That's a good piece of work right there. And also nuclear decay and cosmology. So Russ is into those general areas there. I'm not going to go on too much about the other stuff. I guess you're familiar, perhaps most of you, with his book, Starlight in Time. And that's been out there for a while. And he's, of course, I mentioned the Age of the Earth radioisotopes publication of ICR. So he's also got paper in there, too. Tonight, the topic is New View of Gravity Helps Creation Cosmology. So here's Russ. Thank you.
I'm curious, how many of you have been here since the beginning of your organization? Several of you. Good for you. I feel a sort of attachment to Rocky Mountain Creation Fellowship because I think some words of mine at a Ken Ham seminar that I was speaking at in Colorado back in the 90s sometime. I think we spoke in Colorado Springs, and we may have come up here also. But at any rate, I remember talking to some of the guys who were in Ken Ham's organizing committee from around here, and I was telling them what great things our Creation Science Fellowship in Albuquerque was doing. It turned out to be a really good thing. And I said, we got our start by having a sign-up sheet at a Ken Ham crusade, shall I call it. So I said, maybe you guys can do that too. And I think you did that, and I think that was the sort of the nucleus of your organization. Is that right? So anyhow, I also have another special attachment to Colorado because, as Ed was saying, I got saved here in 1969 as a grad student. I was with LSU, but we were building a cosmic ray lab in the mountains, and my wife and I attended a small mountain church in Dillon, Colorado, and those people were instrumental in introducing me to the Lord Jesus Christ, and I got saved in the middle of a woods all by myself and the Lord just outside Frisco, Colorado in July of '69. So anyhow, land of my spiritual birth, and I feel a special attachment to this place.
Good things happen in Colorado.
Yeah, a few good things, yeah. This is a great place. It feels good to be at this altitude, high and dry once more after Chattanooga, low and wet. Okay, well, thank you for your patience with me, my introductory remarks. Some of you have read my book, Starlight and Time. That was written in 1994, and in 2008, I introduced a second cosmology. It sort of branched out in a different direction from the same roots as the first cosmology, but that hadn't been well publicized. It's in the Journal of Creation, December 2008, and it's just part of one article. But I've been developing that, and tonight I'm going to kind of give you the behind-the-scenes thing that I had in mind, and actually I've had in mind since 2 months after I got saved. I've had this view of gravity cooking on the back burner all this time, so I'm going to dump it on you now. So hold on to your hats. There are going to be some things that are just plain hard to understand, but I can only make them so simple, and the things themselves are just going to be strange to you. So, fair warning. Okay, a new view of gravity helps creation cosmology. It explains a number of different things. Wonder why the clicker isn't working. Here. Cosmic microwaves, microwave background radiation, you've heard of that, and how starlight got here. And then galaxy redshifts. I won't really have a chance to talk in detail about that tonight. And the Pioneer space probe anomaly. It's an anomalous slowing down of space probes that are very far outside the solar system now. And this new cosmology has a lot to do with that. But I won't get much chance to talk about that either. So this new view of gravity comes mainly from Scripture. I'll cite scriptures to say that the heavens are a membrane or a fabric. It's a real material. And we'll get into that. See, that's hard already, right? The heavens, that's space itself. Now, you can't feel space, you know. You can't see space. So here I am saying it's a material, a real material. Now, that's all right. That's our first weird thing. The membrane is 4-dimensional, not 3-dimensional, 4 space dimensions. And that's your second weird thing. That's if the first one didn't kill you, this one will. So I'm sorry. And then I'm suggesting, based on a couple of scriptures, that this membrane is accelerating. And if you have this kind of membrane accelerating, you get gravity. And I'll show you how that happens. So first, let's go back to the very beginning and study what the heavens are and are not. The heavens are space itself. I want to convince you of that. In the beginning, God created the heavens and the earth was formless and void, and darkness was on the face of the deep, and the Spirit of God was moving on the face of the waters. Now, that little word "and" there in the Hebrew is, there are several types of that conjunction in Hebrew. And this use of the word "and," the construction in the Hebrew, says that it connects, it amplifies that first sentence. So in other words, there's another type of "and" in Hebrew that talks about an action that is consecutive, that's after the first action. But this is not that type of "and." This "and" is describing how the earth was. You could translate it, now the earth was formless and void. So God made the heavens and the earth, and right then the earth is formless and void. And so there's the earth, and I didn't know how to draw a formless and void thing, so that's as good as I could get. But darkness was on the face of something, the deep. And you can guess that that's probably waters, because right after that there's the face of the waters. And later on in the same chapter, you find out that the earth is something that's way down near the center of that big ball of water, the deep. So the earth and the deep are one thing that happened right at the beginning, but God also created something else at that same time. What's that? Well, you'd think it's just this stuff around the earth and the deep, the heavens, okay? So he created two things, and one was the earth and the other was the heavens, but he didn't create the host of the heavens till the fourth day. The host of the heavens are the things in it, the sun, moon, and stars. So this looks like just a big empty nothingness, right? The heavens are a created nothing, right? Well, I'm going to say, scratch out the N-O there. The heavens are a created thing. And here's why. Here are the scriptures that make me believe that. The heavens are a real material. First, oh, that thou wouldst rend the heavens and come down. In Isaiah, rend, tear. It's kind of hard to tear nothing, right? And all of them, the heavens, will wear out like a garment. And that's Psalm 102, verse 26. Again, how do you wear out a nothingness? I'm going to shake the heavens and the earth. It's a something that somehow will get shaken. That's a future event. And so it talks about an earthquake, but also a heaven quake. So the heavens can get shaken. There is something. The heavens will be destroyed by burning, says Peter. And the heaven was split apart like a scroll. And there's a couple of other verses that I'll touch on in a moment that also indicate that it's a real material. Now, a lot of these are comparable to a fabric, tearing, wearing out like a garment. So I like to talk about the fabric of space. So, if so, though, it's an invisible fabric that you can't feel as you move through it, and it moves through you. So this is mind-blowing, isn't it? Okay? All I'm doing, though, is taking those scriptural, I would say more than hints, very very seriously. Now, there's some science behind this idea that the heavens or space is a material. So let's look at the science. 19th century scientists knew that space is a material. James Clerk Maxwell, I think possibly the greatest theoretical physicist in the 19th century, was a creationist and a Christian, very fine Christian. And he didn't like evolution and said so. But Maxwell talked about something called a displacement current, and it occurs in an insulator. So if those of you who are electrical EE types, you'll recognize the battery and the resistor and a capacitor with plastic in it. And then there's this symbol for what Maxwell would call a galvanometer, or just an ammeter, and a switch. And in plastic, we know there are what they call bound electric charges. They're in the molecules and atoms. And think of these as positive and negative electric charges that are held together by a spring, okay? But they're really molecules and atoms that are springy. And when you apply when you apply a voltage to those plates, it applies a force to those electric charges and tends to pull them apart. And that motion of charges, it makes a measurable current. So electric charges are bound together. And now keep your eye on the charges and the ammeter and the switch. Okay, here we go. Charges pulling apart, current. Now the current stops. The switch is still closed, but the charges have stopped moving. They've gone as far as that voltage will make them. So there's no more current. So there's a surge of current. Now, what happens when you take the plastic out? Let me just see where I am in this. Let's just take away the plastic. And we'll see that even a vacuum, if we put a vacuum between those plates, even a vacuum has a displacement current. So keep your eye on the ammeter and the switch again. Little surge of current, not as much as when the plastic was there, but definitely measurable. So Maxwell said, well, even though it doesn't look like there's anything there, there must be bound electric charges in the vacuum. So now I'll show those electric charges and show the switch and the ammeter and show those electric charges moving, even though we can't see them really. Okay? If you bring it up here, I will stomp it for you. Yeah. I'm not quite in the 21st century yet. I don't use social media. I'm very antisocial. But Mr. Maxwell looked at all this and he said, I'm going to call that stuff the ether. There was some historical precedence, but he called it the ether. And from this displacement current, he actually figured that there would be electromagnetic waves that move through the ether, and he could calculate their speed, and that agreed with the previously measured speed of visible light. So he said light is probably an electromagnetic wave. But all of that's based on his understanding of the vacuum as having something in it, that it's an invisible, untouchable stuff. See what I'm saying? So in the 19th century, they were pretty happy with that. Nobody minded that concept. But then Einstein came along, and first he discounted, and then he accepted an ether. People know about his discounting. That's in 1905. The introduction of a luminiferous ether will prove to be superfluous. And that's a picture of him about that age when he was young and more arrogant than a lot of physicists are. But he softened up a little, and in 1920, he said this: according to general relativity, space without ether is unthinkable. So in 1905, he threw away the ether. Now he's grabbing it back in 1920. Why did he do that? Because in 1916, he did his general theory of relativity, which talks about gravity and talks about space as being some kind of stuff that can be bent. You've heard of the curvature of space. And he says, I'm assigning physical properties to space itself, so it's an ether. Well, the academics of his day didn't like that, and so they just ignored that. Now, Einstein neither withdrew those words, but he didn't repeat them. He didn't push the idea. He saw it wasn't going to go anywhere. So the ether remained in disrepute. It was sort of politically incorrect. But the ether proved to be indispensable. Here's another arrogant young physicist named Paul Dirac. Arrogance is a disease that physicists get. I think we all suffer from it. But Paul Dirac, in 1930, talked about antimatter, and in particular anti-electrons, which are called positrons. And he said there are holes in a vast sea, an invisible sea of electrons. And you rip an electron out of its usual place in the vacuum, and you leave a hole behind, just like in semiconductors. Some of you have heard of holes in electrons. Same sort of concept. Well, he predicted positrons before they were discovered on that basis. And as a matter of fact, later on, Dirac, let's see, when did he write this? He wrote an article. All right, Mr. Dirac. Yeah, Nature, to the journal Nature in 1951. The title was, Is There an Ether? And he generally, pretty well answered the question, yes. Other physicists took him to task for that, but Dirac stuck to his guns. So, and then in the 1950s, there's this very nice theory called quantum electrodynamics. It's very complicated, but it's also very accurate. It's been proved to be very accurate in its predictions. And, but it starts off with the concept that space is filled with some kind of particles. And then in 1980, people started to amplify on that, and they called it the quantum vacuum. How many of you have heard of that phrase, the quantum vacuum? Okay. So now there have been estimates made of how much material is in the quantum vacuum. More than 10 million metric tons of mass, not weight, 10 million metric tons per cubic centimeter, at least, and possibly as much as that very large number of metric tons per cc. And I translate that for you. A quintillion is a billion billion, so it's up to 10 quintillion, 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 quintillion metric tons per cubic centimeter. So it sure sounds like that stuff is awfully massive. And that's the best theoretical physicists we have are talking about that. So they have code names, by the way, for the ether these days. For years they've been using these. It's a way to avoid this archaic, antiquated, politically incorrect term, the ether. So you will see this word, space-time. What's space-time? Well, it's the stuff that can be bent. Or the space-time continuum, or the space-time manifold, or the cosmic substratum, or the plenum, or the quantum vacuum. All these are code names for the ether, okay? So, but an ether by any other name is still a material, okay? So now let's go back to the beginning. And I'm going to say that God spread out this material that he calls the heavens. So God said, let there be an expanse in the midst of the waters, right down there somewhere in the middle. And later on, the earth develops in that little carved out piece of water that's in there. But above it, there's a small empty space that apparently got bigger. And the word expanse means something that's spread out, essentially. For Hebrew, in the Hebrew, rakia, something spread out. So I think he spread out these waters a great deal, big enough to hold all the galaxies, all the stars. You with me on that so far? And then later on, in the same chapter, God called the expanse, or in the King James, the firmament, heavens. So God spread out this material we call the heavens, but he also stretched the material. We have verses like this. God who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. And that's in Isaiah, and there's a bunch of other verses like that. And it used to be that I thought that God stretched out the heavens a great deal. But now I'm looking at what he said he stretched it out, and it's like a tent curtain, like a curtain. So this is a picture of a model, actually a full-scale model of the tabernacle of Israel in the wilderness, and it's about 15 miles north of Eilat at the opening of the Red Sea there, in a small park called Timnah Park. But you notice the curtains on the tabernacle there. You notice they're not sagging. They've been pulled taut so that they won't flap. So the curtains are stretched taut. So the fabric of space, God says he's stretched it. I think it just means he's pulled it taut. If you take a towel or something and pull on it, then you've applied tension to it. It gets a smidgen longer, but it doesn't stretch out tenfold like rubber. So all the material that God compared this stretching to is material that wouldn't stretch very much. So now I don't think that he stretched out space, but that he produced the redshifts in another way. But the fabric of space has tension in it. Okay, now, next big problem. The heavens are four-dimensional because of verses like this one. The heavens will be rolled up like a scroll. So I made a picture of that. There's the heavens. They're being rolled up like a scroll. I suppressed one of the regular space dimensions, but what that means is if you're going to roll a piece of paper up on a table, it has to be thin in one dimension. So the heavens are thick in all three directions that we can see, but they must be thin in another direction that we can't see. And moreover, to roll them up requires more of that fourth direction. So there's the fourth direction arrow, and there's room. You have to have room to roll this up in the fourth direction. Are you now totally zapped? I hope you're with me. Those of you who were raised on 1940s and 1950s science fiction like I was, you have no problem with this, but So, but this fourth direction, the science fiction people and now scientists also call hyperspace. Now, most scientists have a lot more than 4 dimensions. I'm not proposing 10 or 11 or 22 dimensions, just one, but I'm borrowing their term hyperspace for that extra space that this sheet would exist in. Now also remember that this is a future thing. Today, the heavens must be unrolled if he's going to, in the future, roll them up. So they must be almost flat. The fourth dimension is not time. Relativity treats time as a dimension also, but in this case it would be a fifth dimension, and it's has some differences than the other four space dimensions. So the fourth dimension is a space dimension, even though we can't see it. I think we're bound up within that fabric, and we can't look in that direction. We're not built to perceive in that direction. So, but that fourth direction allows Einstein's curved space. It allows a direction for space to be curved in. So it makes sense of general relativity, actually. So now all we have to do is add some acceleration and we get gravity. Let me illustrate this. Some of you have seen this picture before. Imagine a heavy iron ring sitting on a trampoline. But don't imagine it here on Earth. Imagine it way out in space where there's very little gravity. Okay? Then the ring wouldn't make a dent as you see it here. But if you accelerate that membrane in that direction, then it will make a dent. And if you put a little ball or a small object near, let's say we have a little ball here, it's going to tend to slide toward the heavy iron ring. And it will slide faster as it gets closer. So that's how gravity behaves. It's like there's a force pulling that little ball toward the iron ring, and the force gets stronger the closer it gets to the iron ring. So that's like gravity. So it suggests that here's a way to get Newton's gravity, and you get Newton's gravity if you have this happening. You have an acceleration, and I call it g, and that's going to turn out to be a large number. Square it, divide by the tension. So here's acceleration, here's tension, and if that number happens to be 4 pi times Newton's gravitational constant, then you get a fully mathematically consistent picture of gravity. You can get Einstein's equations of gravity from this, but you can also just plain get Newton's equations. So now in this membrane or whatever, think of it sort of like something that can't stretch much, like a membrane on a drum. Okay, it can vibrate, and it can have waves in it, and the wave speed turns out to be the tension divided by the mass of that membrane itself, and then take the square root of that ratio. Now, if that wave speed is the speed of light, then those equations that you get from this picture fit relativity. So I think it is the speed of light. Now, acceleration has this nice benefit for us creationists, and that is that acceleration makes microwaves. A fellow named William Unruh first found out in '76 this thing that's now called the Unruh-Hawking effect. Sometimes Hawking did something that's related to it, and shows that acceleration heats particles. Just in empty space, if you accelerate a particle, it will get hot. And so we have the fabric of space here, and we have a particle in it that's bound in it, but everything's being accelerated, so that particle will get hot, and Unruh said that it will emit radiation, and it's called black body radiation. I'll explain what that is in a moment, but it's essentially microwaves. And here's the temperature that it gets to, and this is the Planck constant, the reduced Planck's constant. Some of you have heard of that. Basic constants in physics. And then there's the acceleration. And then that's the Boltzmann constant, another fundamental constant, of course, the speed of light. So you can, if you know the acceleration, you can calculate the temperature of this stuff. Now, so if the fabric of space is accelerating, we ought to be able to see the radiation from that heating. The fabric of space itself, in other words, will get warm as it accelerates. So we should see this thing called black body radiation that's related to heat in the cosmos. And we observe cosmic microwave black body radiation, the cosmic microwave background radiation. So satellites observe microwaves coming from all directions very uniformly. And here's one of the newer ones called the Planck satellite. And these microwaves have a certain spectrum. And it fits the spectrum from a material that's at 2.725 degrees above absolute zero, degrees Kelvin. And this red curve is the calculated theoretical radiation you would get inside, let's say, an oven with black walls, whose walls were at a temperature of 2.7, etc., degrees Kelvin. And you get a certain intensity and you get certain frequency or wavelength. And that red line is the theoretical calculation of the spectrum of microwaves that you would see. However, it's also got data points in it. They're so tiny, and the error bars are so tiny that they fit entirely within the red line. That's what's observed. So it's actually very remarkable that there aren't any deviations from this spectrum as you look from one direction to the other. They agree to 1 part in 100,000. It's fantastically accurate, actually, and I don't see how the Big Bang could have any mechanism that would generate this temperature this uniformly in all directions, this precisely. But I think we get it automatically. So this, I think, is the temperature of the fabric of space, just due to its acceleration. Okay, this means, by the way, the fabric of space has to be very strong. So there's our acceleration g, and if you calculate the acceleration from our previous stuff, if we plug in that 2.725 degrees Kelvin into that equation, we get a very large number for the acceleration. It's 6.6 times 10 to the 20th meters per second squared. The acceleration of gravity here on Earth is about 10 meters per second squared. So this is a really fast acceleration. And if the acceleration is great, then the tension is great. And from the equations I have, you can just calculate the tension. So there's the tension, there's the acceleration number we plug in, and there's Newton's gravitational constant, and you get a huge number. 1 bar is about 15 pounds per square inch, and that's the atmospheric pressure at sea level. You have a little less up here. You have 12, I think. And anyhow, 1 bar is our atmospheric pressure, but 10 to the 45th bars. So there's a huge tension in this fabric, and yet it doesn't tear. So it must be very strong. So in the New American Standard, Psalm 150 says, "Praise him in the firmament of his power." I'm sorry, that's the King James. New American Standard says, "Praise him in his mighty expanse." So it's mighty, it's powerful, it's something very strong that God made. So it's very massive. The density of that membrane we can get from the tension and just divide by the speed of light squared. Oh, and we get 5.9 times 10 to the 24th metric tons per cc. Now, do you remember the quantum vacuum? this number fits right into the quantum vacuum. The lower limit is 10 to the 7th, then we've got 10 to the 24th, and then we've got 10 to the 91st on the other side. So it's actually kind of a reasonable number according to quantum theorists. Now, this brings up the famous cosmological constant problem. If the vacuum, the quantum vacuum, is this massive, why doesn't that have gravitational effects? Why doesn't that huge mass gravitate? And this is a huge problem in physics. And it's a problem of 120 orders of magnitude between what quantum physics requires for the mass of the vacuum and what we measure. We don't, either that mass has no gravitational effect or it's not there. So this is the huge problem, and if you read about contradictions between quantum theory and gravitation, this is what they mean by that, the cosmological constant problem. The cosmological constant is a number that's proportional to the mass of the vacuum. So what this theory says is that the accelerating force is uniform throughout the fabric, same number. And so what that means is if you don't have any mass on the fabric will be flat if you don't have any additional mass. And it's only additional mass that makes a dent. So this seems too good to be true, actually. So I'm sort of flabbergasted by this one yet. Okay, let's go back to my 2008 cosmology. The waters beyond the stars affect us here. Remember those waters that were above the expanse? Well, there's a Psalm 148, says, "Praise him, highest heavens, and the waters that are above the heavens." That, by the way, if you were thinking the waters above the heavens had anything to do with the Genesis flood, those were supposed to have collapsed. So, and besides, these are billions of light years away, and they're still there in the psalm that was written after the flood. So they're still out there. Now, I think they're mostly ice particles now. It's not some solid shell, but a very tenuous arrangement, spherical arrangement of ice particles, maybe some chunks as big as planets that are water inside and ice outside, but the total mass is a lot. And they have to be out further than we can see with our telescopes to date. So that would make this diameter greater than 24 billion light years. But all the galaxies would be inside that. But they have an effect, even though they're way out there and they're just tenuous, spread over an enormous area. At the start of the fourth day of creation, the earth was the only matter below the waters. Remember, on the third day, he made the waters into the earth, let the dry land appear and the plants. But no other matter out there other than those waters. This makes for a kind of unusual gravity situation. So the waters above are like that ring on the trampoline that I showed you. And inside the ring, it's flat. So that would mean no gravity. If you put a ball bearing inside there, it wouldn't tend to roll to one side or the other, only outside. And that's what the Newton's equations of gravity say about that situation. Also Einstein's, but the waters above had to make a very deep dent. And the mass of the water had to be at least 20 times all the galaxies to make that deep a dent, to do the kinds of things I'm going to tell you about, and to explain the Pioneer anomaly, so that I won't have time to tell you about. So, but it's a lot of mass. It's 20 times the mass of all the gravity of all the galaxies. Now, here's a cross-section of our trampoline. And the vertical axis is also proportional to gravitational energy per unit mass, and that has units of speed squared. And there's a certain depth of gravitational energy, 1/2 c squared, where the equations of general relativity say something very interesting happens. So here's a cross-section of our trampoline, and this is the iron ring, a cross-section of it, representing the waters above, and a little tiny BB somewhere at the center making a little tiny dent. But I'm suggesting that at the beginning of the fourth day of creation, we were in this situation where we were almost at that critical potential. And below that critical potential, the equations appear to say that time does not tick. Nothing happens. No forces, nothing moves. It's dark. And if you were there, you wouldn't know about it. So no time, nothing happens, very dull. Okay. So during the fourth day, though, God created the stars, and I'm giving a particular scenario here where he may have created them in a wave moving out from the earth. So keep your eye on the animation. Did you see that? So I'm proposing a wave of creation. Now, those new star masses would dent the trampoline. So let me show that in animation. There's the wave of new stars going out, and it makes an additional dent, a little bit of more of a dent in the trampoline. And you notice now that everything in the dent has been shoved below that timeless line, below which everything is timeless. So as soon as the new stars go out, boom, everything starts dropping below that critical gravitational potential or gravitational energy. So now, but we've got tension, that God has left some tension in this material, and that's going to tend to pull it up. If you have tension in your trampoline, you suddenly add tension to your trampoline, it's going to pull that iron ring up, as you can imagine that, I think. So let's just imagine it and do an animation here. Now, there's this thing called an event horizon. You see this arrow here? That's the place where time stops, and inside of which time is all stopped. And that is going to move inward as the stretching raises that dent upward. So keep your eye on the event horizon and on the trampoline as we're letting it move upward. Did you see that? So the event horizon has moved inward. Now, let's just simulate that, looking down on our stars on the trampoline, and so timelessness would follow that wave of new stars. So I've already started it here. This is a wave. Actually think of those as galaxies, and inside the Earth has already dropped into the timeless zone. So we're looking down on the trampoline, you see, and we're making a wave of stars, and behind that wave is a black zone with nothing visible in it, where time has stopped. So here you go. And then it's going to recede as the event horizon moves inward, like I showed you. And then right at the end, you notice this little green dot. That's the Earth. Last thing to pop out. So how does that affect what we see and our cosmology? Well, light would follow that shrinking sphere. I colored the sphere purple just so you could see it against the black background. But inside that sphere, there's no time, and it's shrinking. So there we go. So as it's shrinking, light is going to follow. As each galaxy pops out as it's shrinking, light from that galaxy moves in all directions, and some of that light's going to try to follow the sphere and move in with it. So I'm suggesting that Earth time stopped during the fourth day of creation. So it was a 24-hour regular day here. My clicker seems to be getting insensitive here. Starlight arrived during that fourth day, and whatever God did to bring the light here, it looks like he brought it here during the fourth day. Let there be lights in the firmament, the sun and the moon, etc., the greater light, the lesser light. And then it says at the end, and it was so. So whatever cosmology we have, and you know, this is just one speculation mostly, whatever was the real way that God did it, he got it here in a hurry on the fourth day. So Adam could see the further parts of our own Milky Way and our near neighbor galaxy, Andromeda, and a lot of glories in the heavens. In fact, he wouldn't be able to see the nearest star until 4 years later if God hadn't done this. So I think he did this just so we could see. And you get some really good views up there in the mountains at night. I remember some gorgeous views of the Milky Way there. We wouldn't be able to see those even today after 6,000 years. We'd only see just a nearby piece of the Milky Way if God hadn't arranged to get the light here somehow. Okay. The change of dent depth causes redshift. This is a December 2008 Journal of Creation, and my article in there is called New Time Dilation Helps Creation Cosmology. And in that, there's a little equation that gives you the redshift. Lambdas are the ratio of starting and finishing redshifts that get to us. And the phis are the gravitational potential at the star, phi 1, compared to the gravitational potential at Earth. And then the ratio of R's is the expansion ratio. I was allowing for considerable expansion to produce most of the redshift then. But now I'm thinking, and if you remember some of those animations, there wasn't much expansion. The waters above the heavens didn't move out very much at all. So that ratio would be just 1. So essentially, our redshifts would be due just to gravitational potential. And this is a relativistic effect. It's like the length changes. You've heard about things getting shorter as you move through. It's sort of similar to that. It's a relativistic effect. So you can get the redshift out of that. That's as much as I have time to say here. And then the decrease of that dent depth as things move up can explain the Pioneer anomaly, which is this anomalous slowing down of space probes now that they're way out there, more than they can account for with all the gravity they know of. It, again, is a relativity effect. It's would take some time to explain it. It's in the Journal of Creation, August 2007, and I'm preparing an update for the Journal of Creation because there's been a lot of other theories that have popped out trying to explain the same anomaly, and one has gotten sort of popular, but I'll have an update on that. It really looks to me like the guys goofed somehow. I take the numbers in their paper and plug them into well-known equations, and I get different answers. So anyhow, I'll have an update on that. But at least this theory seems to have a nice explanation for that Pioneer anomaly. So creation cosmology is answering questions, and I'll have time to answer some of yours. Do we quit at 8 o'clock sharp? Well, we'll have time for, let's say, 10 minutes of questions. Okay. What causes cosmic microwaves? That's the new thing that this new wrinkle about gravity introduces. How light got here, that's in my 2008 paper. Redshifts, pioneer deceleration, and I'm sure it's going to answer some other interesting things too. Having an extra dimension to play with is great theoretical fun, you know. So I appreciate your patience with me, and but I want you to be able to trust the Bible to be true. Thank you.
Everybody now knows what's going on in space. Good. You did a good job. We do have time for some questions. Actually, before we take them, I want to, well, I don't know. Let's have the questions first, and we'll. Thank you.
How has your theory been received?
Can we give you the mic? Okay? We'll give you the mic. You mind? Or not? You don't want to come to it? Okay. It'd be better to have the mic. Yeah.
Well, if you're recording this, you want
Yeah.
the question to be recorded, or else I'll have to repeat it.
Yes, Dr. Humphreys, how has your theory been received by others, both in the creationist community and in the old earth community?
Well, only creationists have heard it so far. I gave it last month at the Creation Research Society's annual conference, which was in Florence, Kentucky this year at the Creation Museum. And you're the second audience. So you can poll the audience and ask. But it has passed peer review at the Journal of Creation. It had some good but tough reviewers. And I had to adjust things in my paper, things that I just kind of sloughed off and was lazy and didn't develop. The reviewers held my feet to the fire, and I had to explain those things. But it passed, and they were knowledgeable. You can tell that by their understanding. They were quite competent reviewers. How others take it, I don't know. We'll see. But you're in at the beginning of this new view of gravity, that is. There hasn't been much comment on that 2008 article. I think it's too technical, and it hasn't been publicized. I haven't tried to publicize it. So. Another question?
I have 4 questions. I don't know if you can get to all of them. I'll just ask all 4 of them, and you can decide how you want to answer. How about
Okay.
that? First question is on the cosmic microwave background radiation. I've always seen these maps of the sky that they make, and they draw these contour lines on them, implying that it isn't as even directionally as you were saying with those tiny error bars.
Maybe we should stop and answer these one by one. That might be better. The contour maps show differences of 1/100,000th of a degree Kelvin.
That answers that question. Next question is, can you relate your new theory to the things that they are seeing that have caused them to want to invent dark matter and dark energy?
Yes, I think so. I think, in fact, this theory will probably do away with any need for dark matter. It will explain the things that seem to be explained by dark matter in a different way. That's my, first scoping of that question. But the wrinkles that they see, these small perturbations, can have other explanations than the ones they're invoking, and you can explain the same general features of the data that way.
Okay. The next one is, Carmelli's accelerated space-time theory of the, I guess, the early 1990s. He first kind of came up with that. Can you kind of relate? Because it sounds to me like you and he were saying something very similar.
Yeah, John Hartnett was an advocate of
Yeah.
that. Hartnett and Carmelli's theory imagined space-time as being greatly stretched out. But they also said the one key new thing in that theory was that at the time you start stretching it out, right at the center, time would tick a lot slower. So that was a new kind of time dilation. But that was an acceleration in the expansion, so to speak. It's not an acceleration in a fourth direction. So, by the way, John Hartnett is the one who made me realize that God said he stretches out space like a tent curtain. And tent curtains aren't very elastic, and they don't stretch out tenfold. You would need at least a tenfold expansion of space to explain the redshifts of distant galaxies. And he said the material that God compared the stretching to wasn't that stretchable. So he convinced me. So both John and I now don't think there was a huge expansion of space, which means that Carmelli's picture looks like it goes out, altogether. So I haven't asked John that. Do you still believe in Carmelli? So I need to ask him that.
That's a fantastic revelation about it being more like a material than a rubber kind of.
Yeah, but that's what he said. Yeah, so.
My last question has to do with the Pioneer anomaly. Will you allow that?
Yeah.
Because I was trying to get a handle on what you had written several years ago about the Pioneer anomaly, and after reading it, I wasn't completely clear whether you had concluded that the deceleration of those probes was actually a real deceleration, or was it an artifact of the telemetry due to some other relativistic effect? And does that conclusion still hold now?
I am more firm. Back then, yes, you're quite right. That's very perceptive of you to see that. What I showed rigorously was that we would measure a deceleration with the radar pulses going back and forth between the probe. But the question is that a real deceleration? Now I think it is, but I'm still a little bit queasy about that. So I need to work on that.
So then you had concluded that it was just an artifact of the telemetry, but now you're concluding that it's possibly a real deceleration.
Did I say that back in 2007, that it was just an artifact?
Well, you didn't explicitly say it. That's why I was kind of asking the question, because I wasn't real sure.
I wasn't real sure, so I hedged. I just stuck to the measurement and didn't try to say whether it was a real deceleration or not. But now I think it is. And if it is, then it has the potential for explaining the tight orbits of stars in our galaxies. That's one reason they invoke dark matter, is they say there must be some additional matter pulling on those stars to make them follow the tight orbits rather than looser orbits for their speeds. But if it's a real deceleration, then it's a real force, and it's just about the right order of magnitude to explain the galaxy orbits. So we may be able to explain galaxies without dark matter with this. But I haven't gotten into that, and there's lots of ifs, ands, and buts that I keep stumbling over, so that's just future work.
Well, thank you very much.
Let's see, Dr. Humphreys, thank you for your great work and a great presentation. New Scientist published an article recently saying that all of physics is precariously balanced on a wild coincidence of gravity and acceleration. Would your understanding of gravity help explain why they're seeing that as a wild coincidence?
I haven't seen that New Scientist article. Could you amplify why they said that?
I'll be happy to forward that to you.
Okay.
No, I'm not.
But I have an idea. It's talking about that same, maybe it's talking about a new attempt at explaining the cosmological constant problem and why all that matter in the vacuum doesn't gravitate. So it kind of sounds like it's one of those explanations. There have been a lot of attempts. I mean, it's the hugest numerical problem in physics, 120 orders of magnitude. Can you imagine that? One with 120 zeros after it. Let's see, my answer is this, and I was only one with 120 zeros after it factor wrong. So.
Yeah.
And then Dr. Humphreys also, thank you for the code words for ether. That was amazing. I'd never noticed that. And then your theory of gravity and what happened on day 4, are they coupled or could they be decoupled? Are they, you get them either both or one or the other?
I think you could, I mean, they are both, but I'd have to think about the rest of that question. Certainly having that trampoline picture in your head made it easy to present how light got here. So they're connected. So, yeah.
Anyone else?
Hi, switching the subject a little bit to Mercury. I read an article recently, maybe like Physics Today or whatever it was, trying to explain how the Mercury magnetic field or moment is so offset. And so it sounds like they're still scratching their heads about the strange situation there and not even acknowledging that the magnetic moment is decreasing rapidly like you predicted. Could you comment on that?
Okay, yes, that theory, I haven't had a chance to go through it carefully, but it looks like a new variation on the dynamo theory that I critiqued in the last international conference on creationism. I had a long critique. You'll get a hint of where I was going with it by its title. What did I call it? I said Planetary Magnetic Dynamo Theories, a Century of Failure. Because they have been working on them for almost a century, and I analyzed the most popular, the best analytical theory that they've got, and found that the Earth is several orders of magnitude short of being able to even consider having a dynamo work to maintain the Earth's magnetic field. So Mercury, which rotates much slower than the Earth and has a smaller core, should have even less of a chance of having a working dynamo, because the spin, the rate of spin of the planet or of the core has a lot to do with the dynamo theory. So Mercury, if Earth's core can't have a dynamo, looks like Mercury can't have a dynamo either. So whatever new wrinkle they've put on their non-working theory, I have doubts that they will have any real good explanation.
Yeah, and of course, with their billions of years idea, that they expected Mercury to have absolutely nothing.
That's right. Yeah, they've fallen really short on Mercury. So, by the way, the latest space probe measurements show magnetized lava near Mercury's north pole, and it's strongly magnetized. It had to be a field 10 times stronger than today, and that's upsetting for the dynamo theorist. And then it's reversed. So it looks like Mercury has managed to reverse its magnetic field at least once. So we're having a lot of fun with Mercury. I am, and the other guys too, I think. So.
Dr. Humphreys, This is the matter issue in the fabric of space that is just so bizarre to me. How do you explain having all that extra matter without having a gravitational field? I just don't grasp that. Can you give us a little bit more detail
Remember
on that?
the trampoline.
Yeah.
And the trampoline's sitting out in space. Well, better yet, imagine just a sheet of fabric, okay? And let's say there's pressure on the bottom of the sheet. So there's a uniform force per unit area on the sheet, okay? So if it's uniform, then the sheet will accelerate at the same rate everywhere, and there won't be any dents in it. Are you with me there?
Yeah.
Okay. So it doesn't matter how much the sheet weighs, how much mass is in the sheet.
Okay.
So no dents. Only when you put an additional piece of matter on the sheet will there be a dent. So it's only additional matter that makes gravity, not the mass of the sheet itself.
Okay. Now, so when this all happened, did the acceleration occur on day 4, or is it a continuous acceleration?
I think it's a continuous acceleration. Otherwise, we'd be floating.
So
it's what's holding you to the ground.
Okay.
Just that we're feeling, according to this theory, a tiny fraction of that enormous acceleration in the 4th dimension due to the Earth's having bent the fabric of space just a little bit. And so we're feeling a little bit of that. And
Okay.
Okay.
Still not following it.
Okay. Maybe what I should say is there's going to be a paper in the Journal of Creation, and I think it's this December issue that's coming up, where I discuss all these things. And maybe seeing it in print will make it a little less slippery.
Okay. I'll wait for that to come out. One more question.
Yeah.
If these things are true, does that change the relationship between matter and energy? You know, we've got our equations where we've got spinning bodies and conservation of mass and conservation of angular momentum, and we always balance that against the energy. Does the energy equation still work?
Yeah. No change there.
You're accelerating something.
Yeah.
Without having, acceleration takes a force.
So let's say, if you put the pedal to your metal in the car, does physics still work in your car?
Yeah.
Okay.
But, you know, an accelerating body requires energy. An
Yeah.
accelerating
That
universe.
force is putting energy into it. There's energy involved, yes.
Okay. And where is it coming from?
Well, you don't want to know the answer. I do give it in my, okay, here it goes. Hold on to your seats. You know, if that acceleration were all linear in one direction, then in 6,000 years, it's such a huge acceleration, we would have gone an awful long distance in that hyperspace, okay? Now, maybe God made hyperspace that big, I don't know, but it seems to me that it's more likely that it's actually a rotation effect. That, you know, we've got in our hyperspace direction, we've got an acceleration that way. If we have a transverse speed in some other direction perpendicular to that, then that will be like a rotation. So now this is where it's going to get hard. I think it's a rotation in the time direction. One interpretation of time, according to the equations of general relativity, is that the past and the future exist. So our fabric is not just space, it's space-time. And though we just see a narrow slice of the timeward direction, we seem to be moving through it. But according to this interpretation of time, the future exists and the past exists. They're there. And so we can have a rotation in that direction. We can have, imagine a great wheel rotating, and the rotation of the wheel is our fabric of space. Our fabric of space is now the hub of that wheel, and the velocity is carrying us around, but there's an acceleration, a centripetal acceleration. So if you had your, and that way it works out that the tension in the fabric is the force that does the acceleration. There's a nice little mechanical engineering problem you can do of a rotating elastic rim of a wheel. You can figure the tension and the speed, and it turns out that the thing that's doing the centripetal acceleration is the tension. But the energy is coming from the wheel, or from that velocity of rotation. There's lots of other interesting things. There are two scriptures that hint at this that I know of. But I really didn't want to get into that in great detail. But I do, in the Journal of Creation article, in the last section, talk about this possibility that the acceleration is centripetal. And I show a picture of the wheel of time. So okay, you asked for it. Sorry.
All right, there you go. We're all on the wheel.
Okay.
He wants scriptures.
Let's see. One is in James, of all places. And if any of you have a Greek New Testament, you can validate this, what I'm about to tell you. You have one? Okay. Well, look this one up when you get home. Okay, James chapter 3. This is, looks like the King James. The tongue is a fire, a world of iniquity. So is the tongue amidst our members, that it defileth the whole body, and setteth on fire the course of nature, and is set on fire of hell. Now, the course of nature is kind of a pretty loose translation of what it says. You Greek scholars, it says tas trokos tes genesias, the wheel of Genesis, the wheel of Genesis, or the wheel of generations. It's very interesting. Why would he say that if he meant the course of nature? Why didn't he just say the course of nature? Plenty of good ways to say that in Greek. What's this wheel business? And then the other is back in Samuel, 1 Samuel. Always terrible looking through someone else's Bibles. All those nice marks you put in them aren't there. Okay. Maybe you can help me. It's the place where David meets Abigail, and the wife of the fool named Nabal. What chapter is that? Yeah, that sounds right. Okay. Oh, yes. Oh, here it is. Verse 29 of chapter 25, like you said. This is Abigail speaking to David. Says, "Yet a man is risen to pursue thee and to seek thy soul. But the soul of my Lord shall be bound in the bundle of life with the Lord thy God. And the souls of thine enemies, them shall he sling out as of the middle of a sling." souls. There's the souls of his enemies being slung out. So I kind of wonder if that's what God is going to do with unbelievers. They just will get disattached from the fabric of space and but of course, Abigail's referring, and I'm sure what was on her mind, regardless of what the Spirit was saying, what was on her mind was probably she was making a comparison to David's killing Goliath, and then saying all David's enemies will be like that sling stone. But there's a reason why the Spirit of God included that interesting little phrase there. So, and there's all sorts of phrases where Jesus said people will be cast out into the outer darkness, you know. So there's an outer darkness. There must be an inner something that's not darkness, maybe. But cast out, well, if you just let them go like a sling stone, you've really cast them there. So, but, you know, I wish I had more to go on about the acceleration and whether it's centripetal or not. That's the one part of my theory that's problematic. The thing that attracts me to the theory is that it explains 5 rather intriguing mysteries about gravity that we've had, and one of them was the cosmological constant problem. But there's several others. Like why is gravitational mass the same as inertial mass? Why does inertial mass appear to do the same thing as gravity? Well, this whole theory depends on inertial mass, the power of mass to resist acceleration. So there's 3 other interesting mysteries. So, but you can tune into my Journal of Creation paper in December, and I'll go into great detail about that. So,
did you have a question?
I don't know about everybody else, but I'm going to have to watch that presentation several times before a lot of it starts to sink in. So I'm going to ask you a relatively simple question, unless you have an objection to that.
I don't have an objection at all. It's up there in the computer, and you guys can do what you want with it. Okay? No strings attached to it.
Okay.
Just don't tear it into little shreds and make fun of me with it. Okay?
When you talked during your presentation, you showed a video depiction of the beginning. From what I understand, there are more than one Big Bang theory. Does this disprove the Big Bang theory? Can you list however many there are right now and what the scientists subscribe to at this point? I think there's a hesitation, and I don't remember what else. So, does this disprove that?
You mean my new theory?
Yes.
Kind of hard for a theory to disprove another theory, but yeah, it's just a battle of words. But yeah, I think the inflation form of the Big Bang. You've heard of inflationary Big Bang theory, very rapid inflation of space in a very short time. That's to solve certain problems that they have. But it predicts that there will be 30 times more matter in the universe than we see. And so that's called the dark matter problem, or they can have some of that be dark energy, pretty much the same stuff. But they haven't found the dark matter. So this would do away with the need for dark matter altogether. So it kind of just like cuts out one of the pegs underneath. And then where it also I think provides a better explanation for the cosmic microwave background radiation. Why should it be that uniform from all directions? If you've got a big exploding ball of plasma and we're seeing the red-shifted remnants of that, why isn't that plasma more ragged? Explosions don't tend to be nice and regular and have the same temperature all over, So.
Thank you.
Yes, sir.
recently Hawking said something about if you had gravity, you could create the universe with just gravity. It seems to me what you're saying is gravity was created on one of these days. Was gravity always there, or it had to be created at some point?
Well,
Because it's related to
it
mass.
may have changed, but it's just from the fact that the Spirit of God was moving on the face of the waters, and darkness was on the face of the deep or above, and the fact that the deep had a surface. All of those point to gravity existing right then. But it may have been less, and the tension may have been less on that day than it was later. He might have, on the same day he was spreading out the heavens, spreading like a tent, he may have been stretching it out, applying more tension. So that would change gravity. So gravity might have been different on the first day than on the second and the remaining days. So.
Your construct is making gravity.
Is what?
Your construct is making gravity.
Yeah. So, I don't know.
Read the journal article.
Well, I don't think it'll solve that one. So
Wouldn't solve that one. Okay.
He'd have to tell me whether or not he changed the acceleration as well as the tension. So, or
Yes.
he might tell me, that's all baloney, Russ. Yeah.
I don't know if this is quite appropriate to ask, but would you say that John Hartnett is distancing himself from his own theory and attributing the significance?
I need to really ask him that, but it seems like since he's done away with the great expansion that the Carmeli theory was essentially built upon.
Right.
If that didn't happen, I think he is moving away from that. But I need to ask him that.
Right. Well, thank you.
All right, let's give Dr. Humphreys another hand, please.
Thank you.
You're a good group because he has some good responses for you. So, yeah. Well, listen, what was passed out, I hope everyone got a copy, is about the celebration of Creation Weekend, which is discussed in this handout. I'm not going to read it over. You can read it. But we try to make this an annual event. We call it, Adam's birthday, if you want to put it that way. And coincident with Rosh Hashanah. But here at Calvary Apostolic Church on September the 21st, 6:30 p.m., there will be a celebration of this event. We had it at Gino Geraci's church last year, and we hope we get it to different churches, going on and on. Hopefully spread it to your own home church, too, if you can do that, make some impact. We can get you more of these things to pass out if you want. So by all means, make a note of this on your calendar, get the word around, and let's have a great time of celebration and worship of God's day of creation. Okay? Thank you. So don't forget, we will break for fellowship and so on downstairs. Can't tell you about October's speaker because I don't have one lined up. So it may be a last-minute thing, but we don't know yet. We had several possibilities that we tried to get a speaker, and one thing or another happened, so just kind of didn't work out. And it's kind of late date right now, but we still may get some. If not, we'll probably have a video and discussion like we've had once before. So that's always entertaining, too. Okay, thank you so much, and God bless.